Hello and welcome to another episode of CISO Tradecraft, the podcast that provides you with the information, knowledge, and wisdom to be a more effective cybersecurity leader. My name is G. Mark Hardy, and today we're going to investigate how our systems ensure that only the right humans can do only the right things. As always, please follow us on LinkedIn and make sure you subscribe so you can always get the latest updates. Today we're going to talk about identity and access management. And specifically, we shall focus on two topics of interest: access control and authentication. It'll be an overview to help you understand the benefits and disadvantages of various approaches and show you how the industry is shifting. First of all, let's define a few terms. TechTarget defines access control as, quote, a security technique that regulates who or what can view or use resources in a computing environment. It is a fundamental concept in security that minimizes risk to the business or organization. Access control systems perform identification, authentication, and authorization of users and entities by evaluating required login credentials. NIST defines authorization as, quote, the right or a permission that is granted to a system entity to access a system resource, quote, and authentication as, quote, verifying the identity of a user, process, or device, often as a prerequisite to allowing access to resources in an information system. We'll now get into some different strategies. Now, a lot of this material comes from Aaron Risk's blog on twingate.com. In access control methodologies, there's a variety of ways to restrict access. Number one is the mandatory access control, or MAC. That's our first method. This is a security strategy that gives a user an attribute. We can think of folks in the military who are granted a secret clearance. They would allow them eligibility to view secret material without it being an incident. Next, any objects such as files, databases, or devices would be given a classification. They might be classified as unclassified, confidential, secret, or even top secret. Thus, an employee with a secret clearance would have the ability to view unclassified, confidential, and secret content, but should not have the ability to view top secret material. Now, this is an easy way to protect against unauthorized data disclosure. You can then implement mandatory access control software that first validates if a user has sufficient clearance to view a file, or you could create different networks that have different classifications. In DoD, there are NIPR, CIPR, and JWICs, the unclassified, secret, and top secret networks. Okay, not going to get into the details on that. That's kind of beyond the scope of this program. But by only granting network access based on clearance, this reduces the risk of somebody accessing material above their clearance level. Now, the advantages of MAC includes enforceability. As an administrator, you set organization-wide policies, and users can't override them, so now enforcement is pretty straightforward and easy. It also provides compartmentalization. You can limit the exposure of resources to a subset of the user base so that by having these security labels, we know that we can determine who probably had access to something if there were an issue. Now, of course, there's some disadvantages to just about everything, and Mac has them as well. It tends to constrain communication, and therefore it tends to hurt collaboration. If you're a highly collaborative organization, you might need a little bit less restrictive approach. In addition, it creates a management burden. You have to have a dedicated organizational structure to create and maintain security labels. And quite honestly, if that's not part of your organizational culture, that's very hard to do. Having worked in both in the military and in the civilian world, I got to tell you that the thought process of being able to go back, particularly for a company that has not done this before, and label every single document, or do it like we do in DoD, and label every single paragraph, tends to be a tremendous amount of work that a lot of organizations don't want to do. So, as an alternative to mandatory access control, the next access control methodology is discretionary access control, or DAC. Discretionary access control tries to focus on the object more and provide least privilege. Consider that with a mandatory access control, a person with a secret clearance might be able to access a lot more secret material than required by the job description, which could be a problem. Discretionary access control allows the owner of a resource to explicitly list who has read, write, and execute access to the file or folder. And this is done via an access control list, or ACL. Now, while this may sound better, it can also provide some problems and be a little bit difficult to maintain. For example, let's say John's on the engineering team and he needs access to the design documents. he gets access to them and he's able to get the work done. But if John later leaves the engineering team, he may no longer be in a role that requires access. Yet in this example, if John had access to hundreds of folders and files, then we need the owners of those items to manually remove John's access when he changes positions. And of course, this doesn't always happen. Now, the advantage of discretionary access control is it's very simplistic from a conceptual perspective. An access control list, or ACL, will pair a user with an access privilege. As long as users are in the table and have the appropriate privilege, they can access the resource. And it stays responsive to business needs. Now we don't have to go through a security administrator. We don't have a bottleneck trying to get all these things done because each owner can go ahead and assign those access controls respectively. Now, what are the disadvantages? Well, you could end up with users, as we kind of alluded to before, being overprivileged. They end up having a lot more rights than they should, and quite honestly, if you think about it in this scenario, access rights may come and go, but they usually accumulate. There's also a problem of limited control. As a security administrator, you don't easily get a resource as to how all your different attributes are assigned within the organization. Who is viewing what? Who can view what? And the like. And although viewing a resource access control list is straightforward, if you want to see a particular user's privilege, you got to go through every single ACL to try to figure that out. And there's a risk of compromised security because if users get discretion over access policies, then sometimes they just want to make it easy, and therefore they just open it wide open, and therefore you end up with a problem that could undermine your organization's security posture. So we've talked about mandatory access control and discretionary access control. Another approach is role-based access control, or RBAC. Role-based access control kind of realizes the limitations of trying to get owners to assign and remove access and tries to minimize that burden. In RBAC, a user is given access to a role or a group. These roles and groups are given access to various objects such as files, folders, applications, etc. And then when someone comes into an organization, you just assign the individual a role which could provide access to all the correct files and folders that are associated with that particular job task. Now, this is a huge help when you want to clone one employee's profile to another. And also when somebody leaves the organization, you just simply remove them from the role, and that work is fairly straightforward to perform. The advantages of role-based authentication is what? Flexibility. Because what you can do is you can assign users to multiple roles, create different hierarchies, and therefore you can define relationships between the roles and ensure that people, if they're playing 2 or 3 or 4 different assignments or they're on a temporary assignment, get access to what they need. But when they leave that temporary assignment, you can pull it very quickly. It's very easy to maintain. If you've got well-defined roles, really it's just onboarding and offboarding and maybe cross-boarding users' roles, but you're not trying to create new sets of privileges every time somebody comes on board. You've got centralized policies, and they're not really discretionary. You can set consistent policies across the organization, and unlike the discretionary access control, it's going to be consistent. And you have lower risk exposure because users only get access to the resources that they're needed for their particular job role. It limits potential threat vectors. Now, what are disadvantages? It's complex deployment because trying to figure out this web of responsibilities and relationships is so complicated that it even has created its own little subfield of role engineering. Plus, you have to balance security with simplicity. If you have a lot more roles and a lot more granular roles, it's great for security. But if you got all these overlapping roles, maybe even in the dozens, it's going to be very, very difficult to manage that. And finally, if you look at layered roles and permissions, if you get too many roles to a particular user or you forget to take them away, they end up with over-privileging users. And again, that's an issue that we saw before with discretionary access control and to a certain extent excessive access for only having mandatory access control. A newer type of access control is privileged access management, or PAM. PAM focuses on providing limited or ephemeral access on an as-needed basis. I mean, let's face it, most employees don't need admin access. However, there are times when they need to install a new piece of software. So PAM can be used to create a one-time code to install a piece of software with admin access. And after that access is done, the code's no longer active. One and done. Now, the advantages of PAM is you reduce your threat surface. Now, common passwords, shared credentials, all these manual processes, we don't have to do that anymore. We can impose best practices and avoid those security risks. You can also minimize the creep of permissions because you can revoke privileges when users don't need them, and therefore this tends to work against that sense of accumulating and collecting access privileges. And in addition, PAM gives you auditable logging. You can monitor users for unusual behavior, and it's a lot easier to see what happens when you've got a system where you have all of these different rights that have been set up and defined, and again, they sunset when they're no longer needed. Now, the disadvantage is, kind of internal resistance. I mean, some people say doctors make the worst patients, so IT professionals will probably be the people who are going to resist the security measures the most as compared to your end users who might just accept it as a part of their job. In addition, it's complex and involves some cost in terms of time and money. And a lot of organizations are already constrained for both, and it's a little bit difficult to get all of that together. The next approach is rule-based access control. Now, Mike Maxenti of Genea has written that, quote, rule-based access control manages access to areas, devices, or databases according to a predetermined set of rules or access permissions, regardless of their role or position in an organization. Quote. Now, this is a security model in which a system administrator defines a set of rules based upon conditions, such as time of day or location. For example, if working hours are 9 to 5 Monday through Friday, a rule-based control might limit access to users to those hours only. Now, presumably the administrator and incident response handlers would be exempt from those restrictions. But it's not uncommon to use some form of both rule-based access control and RBAC to enforce access policies and procedures. Well, although they both are RBAC, we tend to use the RBAC exclusively for role-based access control, not the rule-based access control. Now, what do we have in terms of benefits? We've got some flexibility. Businesses can adopt rule-based access control because now we can go ahead and then say, hey, this is our normal working hours, this is the building people work on, etc. And for larger organizations, there could be value in having flexible access control policies because now system administrators can restrict access to some of the systems or even parts of the building only during certain days of the week, and they get a lot of flexibility, which is a major benefit for rule-based access control. Now, on the downside, the biggest drawback is the amount of hands-on administrative work that these systems require. And because the rules have to be consistently monitored and potentially changed from time to time, these systems can either be very laborious or in a bit more hands-on than administrators want to be, or privileges get out of date, and we end up with the problem we talked about before, where privileges tend to accumulate. And the last we want to look at is attribute-based access control, or ABAC. It's also known as policy-based access control. Now here, access rights are granted to users by combining attributes into a policy. And then using a logic tree of if, then, else, you can program these access rules. For example, if the user is the document owner, then allow rewrite access to the file. Else, if the user is in the same department as the document owner, then allow read access to the file and deny access on weekends. Else, for all other users, deny access. Now note that ABAC doesn't have predefined roles like RBAC. Rather, it's the logic tree that creates the enforced policy. And this methodology manages access rights by evaluating a set of rules, policies, and relationships using the attributes of users, systems, and environmental conditions. Now note that attributes can be about the subject, for example, job role, title, clearance. It could be about the action, for example, read, write, change, delete. The object, is it a database, an application, a record, and the context or the environment, for example, time or location. So to recap, we have number 1, mandatory access control or MAC. Number 2, discretionary access control or DAC. Number 3, role-based access control or RBAC. Number 4, privileged access management or PAM. Number 5, rule-based access control, which I mentioned before isn't called RBAC to avoid confusion. And number 6, attribute-based access control or ABAC. Okay, now that we've looked at access control, let's turn our attention to authentication technologies. As we said before, authentication is verifying the identity of a user, process, or device to allow access. The first is password-based authentication. They're the most common methods of authentication. We all know them, we all use them. But there is a saying that says passwords should be treated like underwear. Don't reuse them and definitely don't share them with others. Now, I guess the one thing where that underwear analogy might fall apart is passwords should be long. The longer, the better. Now, using long passphrases makes it harder for bad actors to guess or brute force a password. Maybe we can call this the Long John approach to keep you warm. But one side note, if you are using passwords, consider trying a password manager if you don't utilize one. It can make a lot of long, complex passwords, and then after generating them automatically, save them so you don't have to remember any one of them. All you have is one master password, and that could be particularly long but memorable, and then the system takes care of everything else. Number 2 is certificate-based authentication. Instead of using passwords, another popular approach is use a digital certificate, also known as an X509 certificate in the web browser. These certificates contain a user identity that can be used in transport layer security, digital signatures, and certificate revocation lists. Certificates commonly have a validity period, and we can think of these like a driver's license. You can use it till the expiration date comes, and then you need to renew your license. Additionally, if you get too many speeding tickets, then you can have your access revoked. The biggest weakness is if the root certificate becomes compromised, then potentially every user certificate does. In 2011, DigiNotar lost their root certificate keys, and as a result, attackers were able to produce at will valid certificates for any site. Well, what happens in a situation like that? Do you just say, hey, we'll keep everybody that has been approved prior to this date on, and then everybody after that could be considered compromised? No, because the attackers could have backdated certs when they issued them. Remember, they got the keys to the kingdom. It's like they stole a passport issuing machine. You've got to invalidate it all. And DigiNotar went out of business. So that's kind of an extreme example, but there have been times where parts of public key infrastructure have been compromised. Komodo had that happen as well. And not trying to pick on anybody, but it does happen from time to time. And so there's a concern there that introduces a potential vulnerability. Number 3 is a token-based authentication. And a token-based authentication is token's a small device that generates a random number or value every time it's used. Think of things such as the secure ID token. And some look like key fobs. They can display a 6-digit number you can use. Others store digital certificates or digital signatures. And there's also electronic versions of tokens. I mean, common examples would be like the Google Authenticator or Authy. Microsoft has their own authenticator. And these devices get installed on your phone via mobile app, and then users can retrieve a code when logging in to a website or into their email or even into admin portal as a form of multi-factor authentication. Number 4 is biometric authentication. And biometric authentication is becoming a common form of authentication. It's convenient and it's often built into new phones and some of the things, laptops as well. I mean, common examples include Apple Face ID. It'll scan your face, or Touch ID, which can use your fingerprint. And the convenience of not having to look up a password or key the whole thing in makes these commonly used for mobile applications and authentications. As I said, they also have it commonly found on laptops. I've got a fingerprint reader on my Dell that I use in my client. However, it seems to forget who I am a lot, and I end up often typing in a PIN. Probably 3 times as often I'll do a PIN as I'll actually get it to recognize my fingerprint. So recognize these are not fail-safe. The other concern to think about from a biometrically activated credential is that if you are accosted by, let's say, a criminal who's trying to get you to empty out your bank account or your Bitcoin or whatever you happen to have that you can access through your cell phone, all they have to do is hold this thing up to your face or force your finger onto it, and boom, it goes. So if, for example, you think you're about to be captured by bad guys, if you got an iPhone, press the power button on the side 5 times. What that does is it temporarily disables your biometric authentication and requires a login with a PIN or a password to go from there. I mean, you may someone holding you at risk, you still might give them that, but at least it slows it down a little bit. Next is a concept we've kind of alluded to of 2-factor authentication or multi-factor authentication, written as 2FA or MFA. Now, some combination of these above techniques, which is going to be some password, a certificate, a token, or biometric, or the combination thereof, is going to increase the likelihood that the entity that is attempting access is indeed who you think it is. Now, as you might imagine, 2FA is two of the above. For example, password and SMS message. MFA technically includes 2FA, but it could provide even more methods. For example, if you needed access to a top secret military space, they may require an access card and a PIN and a fingerprint. And so now you're at 3-factor authentication. The next approach is location-based authentication, and this is fairly new, a relatively new method that's been enabled for cell phones with the widespread availability of GPS, and for fixed devices based upon geolocation of IP address. Your banking application probably uses this method in combinations with others, such as a password. Now, a login attempt from a known dangerous location may result in denial of access, even if the password are correct. Now, sometimes this is also called transaction authentication. I've noticed that when I've traveled in Europe, some of my American airlines, I think it's Southwest, which doesn't fly to Europe, when I try to access their management portal for my corporate account, says you're not allowed to log in because you're outside of our footprint. Well, fine, you just go ahead and log in through a VPN and around you go. However, I have noticed that some banking software has gone through and apparently cataloged the exit nodes for VPNs in the United States and maybe other places. And if you try to come in through a VPN, they go, no, we can't geolocate you, so we're not going to let you use your application. So be careful with location-based authentication. It gives you some pretty good tools, but what it might end up doing is a false positive. And therefore, I would encourage, if you're going to use location-based authentication, use that in addition to other methods and provide some way to kind of do a command override by asking for a third or additional authorization method or authentication method to let somebody in. The next approach is computer recognition authentication. This is what we see when we get the message, this PC doesn't currently meet the minimum system requirements to run Windows 11. You've seen that? Yeah, I've seen that. It's on the machine I'm on right now. It's on my laptop. And so I'm going to be buying new hardware at some point. Why? Because one of the requirements for Windows 11 is a Trusted Platform Module, or TPM. Now, this physical edition of the motherboard allows absolute determination of device identity. Now, note that cookies are a more ephemeral way of providing computer recognition authentication. Clicking the box on a website, remember this computer, or remember me, it deposits a small piece of information on the machine that can be pulled later by the same website to verify if you've been there before. The next is a Captcha code. Now, here's a Hacker Jeopardy question for you. Captcha stands for what? Completely automated public Turing test to tell computers and humans apart. There, now you know. It doesn't so much authenticate an individual user as to differentiate from an automated bot attempting to gain access and against that versus a human. Now, we've all experienced these before. They're not so much for verifying that you are you, but that you are not a computer. Now, it's interesting looking at some of the methods that have been used to try to get around CAPTCHAs. People have written software that is designed to learn over time and improve their accuracy. And there's even situations where organizations have gone to low-cost parts of the world, and they've basically created CAPTCHA entering farms. So as a result, a CAPTCHA is relayed over to a human, and they could go ahead and answer this stuff. And sometimes you can end up a person doing hundreds of these things per hour, maybe probably thousands. Not very exciting work, but it pays, and it doesn't pay a whole lot, but it might be used in a situation where someone's trying to brute force, and then you can outsource that to somebody whose cost of labor isn't that high. So CAPTCHAs are helpful, but they're not absolute. The next is a single sign-on, or SSO. Single sign-on enables the user to enter credentials once and then access multiple systems or applications. Now, this is a convenience for users who might otherwise have to log into multiple sites throughout the day, but also represents a potential risk if an attacker gains control of an SSO session. Now, if you remember Bruce Schneier's quote that complexity is the enemy of security, it's also true that convenience is the enemy of security. And then finally, we have risk-based authentication. So we've mentioned passwords, certificates, tokens, biometrics, other things such as that. You've likely seen these before. What's kind of new in the authentication space, instead of something you know, Password, something you have. Token, something you are. Biometric, somewhere you are. Location. Risk-based authentication uses attributes about you to determine a risk measure. For example, when you log into a website, the site your laptop reveals your login device, and then your web browser strings, your IP address reputation, your geolocation. Remember, we've talked about some of these things already. But these factors can be evaluated from previous logins to determine if you are logging in from an unknown device or location. And if your login is from a known device and location, then maybe the website lowers its requirements for authentication. It might only require a username and a password. However, if you're logging in from an unknown device or location, the software may challenge users to provide multi-factor authentication by asking for a token. Overall, the focus is on the user experience and ideally providing a little bit less friction to the user. In a way, Microsoft conditional access tends to do that. You come in from a very strange place, and you've got to be careful how you set your rules, whether it's low, medium, high risk. When I was in Europe fairly recently, as I tried to log in as an admin, it says, well, your account may be at risk. Well, of course, my IP address just hopped from the US over to Europe. But then, because of the policy that we had set up, it says we have to change your password. It's like, I don't want to change my password. I am the administrator. I don't need it. I know I'm safe. And so I had to go back and change the rules on that a little bit. And that's pretty much what that has, is that you can either lock the individual out, or you can make them do a password change, or you can do nothing. Well, how do you get around that? If you're the global administrator in an Azure domain and you're highly mobile, or you know you're going to be moving around, you might trigger a few false positives. And so therefore, you have to think carefully. Do I create an exception for this particular account, which is not really the best thing to create an exception on because it's got the most privileges of all. Anyway, you make your own decisions based upon your risk tolerance. Now, different technologies can use different combinations of these techniques. For example, BitLocker can use a TPM, which is the computer recognition. You can log in with a PIN, that's password-based. Or it could be a startup key, that's token-based. And that will then allow a system or a drive to become accessible. But some of the best defenses against a skilled attacker with physical access are not enabled by default. And if you go through and take a look at Microsoft's comments, I've also got links in the show notes, you can find out that if that's what your risk profile is, somebody actually grabbing a machine and then going at it with a screwdriver and some other tools, there's some additional security you can put on it. But again, in most environments, convenience is going to trump security. So to summarize, authentication can be accomplished through 1, password-based authentication. 2, certificate-based authentication. 3, token-based authentication. 4, biometric authentication. 5, kind of a combination of the above, 2FA or MFA. 6, location-based authentication, which I suppose could go into the MFA. 7, computer recognition authentication. 8, Captcha code. 9, single sign-on. And then 10, risk-based authentication. Okay, so today we covered 6 forms of access control and 10 methods of authentication. I'm sure there are probably others as well that some of you may have heard of or even invented. The important point is knowing who is accessing a system and ensuring that that user can do only what is permitted. And that goes a long way towards securing your enterprise and reducing your risk. Well, thanks again for listening. We'd like to thank our listeners for their ideas and suggestions for the show. For example, one of our listeners named Mike was our inspiration for writing the episode on software supply chain risks. And we've been thinking about how we can add more elements of our show to involve listeners, so we're considering introducing a new segment of our show called Monday Morning Email. The thought is this. Imagine that you're a CISO who just had a relaxing weekend. I guess those exist. And now you receive what's a very tricky email first thing on Monday that requires a well-considered response. Quickly. Now, if you'd like to suggest a topic for the Monday morning inbox, please visit our website, CISOTradecraft.com, and submit a comment. And if we find one that we like and we think it's sufficiently compelling, you might hear it in an upcoming episode. Hey, as a favor, would you please take a moment and leave us a review on Apple Podcasts or however you're listening to us so we can attract more listeners. We hope you've enjoyed this topic and look forward to sharing more content with you next week. Again, this is your host, G. Mark Hardy, and thanks again for listening. Until next time, stay safe.